All right, this represents double-stranded DNA. We have two strands, right, that are anti-parallel to each other. We have the coding strand here, and you know that because I've labeled it to you. I'll always let you know what the coding strand is. So this is our coding strand, and here is the template strand. So what happens in transcription is we need to make an RNA copy of the coding strand. And the reason why we want to do that is we want to leave our DNA safe inside the nucleus and send the instructions out into the cell so the worker, the ribosome, can then build the protein we need from this. So the way this works is RNA polymerase is going to come in and it's going to bind to this promoter region, actually, if you remember the TATA box there. It will bind to that along with a number of other things. And it will, in the process of working, split open our DNA. So the template strand and the coding strand will be broken apart. Now this is how our cell actually does this. What it will do, and I'm going to represent the RNA that's being built, is in blue. So RNA polymerase will come along and it will build a match to the template strand. By match meaning if there's an A in the template, it's going to put a U, not a T, because RNA doesn't use T's, right? Where there's a T, an A, and so on. Okay, now hopefully you can see this, that by matching the template strand, what I have done is I have made an RNA that is the exact same as the coding strand, except where there's a T in the coding strand, I have a U. And so we've built this now RNA that is a match to the template, but an exact copy of the coding strand. Now, for you, as you're working through that, whenever I'm giving you a coding strand, all you need to do is take the T's and replace it with U's, and it will give you the proper RNA code, right? But I wanted to demonstrate to you how this actually works. So what would happen next, right, is this template strand is going to go back and connect to our DNA. It's going to be reformed, right? Those bonds will be remade. And our RNA here will then be processed, right? We talked about how only the exons are what's going to be part of that. So in this case, the exons would just be this region right here. Everything else would be an intron, which would be left out. So these would be intron, exon, and intron. So that is the process of transcription, is when we make the RNA, and then RNA processing, we're going to take that RNA and we are going to remove the introns, leaving only the exons, and then we'll add to this a 5' cap that will go on this end, and a poly A tail that will go, I can't spell, there we go, poly A tail. So that will go on this end. So our exon then has the 5' cap and the poly A tail. If we had many exons, the exons would be linked together like we did in class. And this is now mRNA ready to go out to the ribosomes. And we did that when we did our beads, right, where we practiced that process. So we would start with the start codon, AUG, which codes for MET, and we go codon by codon every 3 letters until we reached a stop codon, which is UGA, and that process would be finished. So that would be translation. So transcription is making the RNA copy of the DNA coding strand. RNA processing, removing the introns, leaving only the exons, and then we add the cap and tail. And then translation would be taking the mRNA at the ribosome and having those codons read 3 letters at a time. Now, we also talked about anticodons. So there are tRNA, which their job is to carry amino acids. So we'd have an amino acid MET being carried by this particular tRNA. The tRNA knows when to come in because it has the complement to the RNA code that we have here, right? So this would be a UAC on here, and that would be the anticodon, okay? And these would come in and they would bind at the ribosome for just a brief time. The MET would be dropped off, and then that would float away to go get another MET, and we would then have the next 3 letters read, and then we would add that amino acid to the chain and so on, forming our protein. So hopefully that clarifies some of the stuff that I felt like some people were struggling with. If you have more questions, please send me an email or see a TA.